Hi and welcome back. In this video on improving the models, we are going to look at regularization and feature scaling. Regularization is a technique which helps us prevent overfitting. The way regularization works is that regularization discourages learning a more complex model. To understand regularization better, let's first look at the original cost function, which is the sum of all the squared errors by 2m. Or you can say C0 is equal to sum of all the squared errors by 2m. The new cost function then becomes C0 plus lambda into sum of all the weights squared. What this basically means is that for higher weights we are penalizing the algorithm and thus increasing its cost. Here lambda is called the regularization parameter. If lambda is 0, we are not penalizing on large weights, and if lambda is large, we are penalizing large weights a lot. When we take the sum of squared weights, it is called as ridge regression or L2 norm. Another way to penalize the weights is to take the sum of absolute weights and then multiply it with lambda. This is called as lasso regression or L1 norm. The difference between L1 and L2 norm is that in the case of L1 norm, we can get weights value of 0, whereas in L2 norm, we usually get really small weights, which means L1 norm can also be used in feature selection. L2 norm penalizes large weights of all the parameters equally, so all weights will be penalized equally irrespective of the input size. To make it more effective, we need to perform feature scaling. Let's say this is the output. Y dash equals to W1 into X1 plus W2 into X2. If Y dash is in the millions and the feature X1 with input range 1 to 10 million will have small weights compared to feature X2 with input range 1 to 100. But if we try to infer something using linear regression in such a case by assessing the weights, it will not mean that the weights for X2 should be regularized more. So we perform feature scaling. Feature scaling also makes our convergence faster. In this section, we saw how to improve our model. In the next section, using support vector machines and random forests for complex problems, we'll use these two algorithms to solve complex problems.